Okay, so today we're going to be taking a look at our final exams, focusing on the Taylor and Maclaurin questions. Okay, which means that the first one I'm going to start off with is the spring 2019, and this is question number 8. So question number 8 says, we want to find the third order Maclaurin. I'll write out as a 0 here. Third order Maclaurin, if we can get that in focus. Okay, third order Maclaurin. Okay, of the function below. So the function that we're working with, e to the minus x over 3. Okay, that's an e. That very clearly. E to the minus x over 3. Okay, so this one they want us to actually derive the Maclaurin. We can't use Maclaurin series substitution. Okay, when we go to find this out, which we do different types of questions using the Maclaurin or Taylor polynomials, we can use substitution, but in this particular case, they want to see us actually derive everything out. Okay, so remember, our third order Maclaurin is going to look something like, we write out the general form. So my third order, okay, it's going to look out my function evaluated at 0 plus my first derivative evaluated at 0 times x to the 1 plus my second derivative evaluated at 0 times x squared all over 2 factorial plus my third derivative evaluated at 0 times x cubed all over 3 factorial. Okay, this is my third order Maclaurin general form. What we need to do is we have to find out what these f prime at 0, f double prime at 0, what these coefficients are so that we can plug them into our general form. Okay, so let's go ahead and start that process. I'm going to set up a table where I have my function. It's going to contain all the derivatives, so I'm going to give myself plenty of room to work. And I have my x equals a, which in this case is equal to 0. So that's where we're going to be evaluating it. Okay, so to start off with, our function that we were given, f of x equals e to the minus x over 3. So that's our first function. Now, I'm going to take that, and I'm going to evaluate that at 0. So that's x equals 0, e to the minus 0 over 3, which is e to the 0. E to the 0 is equal to 1. That's my first coefficient. Now I need to find the derivative. Okay. Remember our derivatives on e to the x, we repeat, okay, the function that we have. So I have e to the minus x over 3. Then I have to do the chain rule and take the derivative. If I take the derivative of minus 1/3 times x, I'm going to get minus 1/3. I'm going to put that coefficient out front. So now I want to take my first derivative, evaluate it where x is equal to 0. So I'm going to get minus 1/3 e to the 0, which is equal to minus 1/3. That's my second coefficient. That's what's going to go here. Second derivative. Okay, I've got my coefficient from before, and I've got my new coefficient, right? So I'm going to go minus 1/3. That comes from my chain rule, times the 1/3 that I had before. Oops. Give me a second. I couldn't say that is breaking. Minus 1/3 from before, e to the minus x over 3. Okay. Now I'm going to take this and I'm going to evaluate that where x equals 0. So I'm going to get positive 1/9 times e to the 0, okay, which just gives me positive 1/9 because e to the 0 is equal to 1. My third derivative, okay, I've got these from before times a new 1/3 e to the minus x over 3. Okay. And then I've got basically, right, minus 1/3 times, this is a minus and a minus, but they cancel out to become positive. So I've got f triple prime, my third derivative, evaluated where x is equal to 0. So it's going to give me minus, because it's minus, minus, minus. So it gives me minus 1 over 3 times 3 times 3 is 27, okay, times e to the 0, which gives us just minus 1 over 27. So this right here, these form the coefficients that I'm going to be placing inside my Taylor, or my Maclaurin. So I'm going to go on the next derivative. I'm going to do my f of n, my nth derivative, because I know I'm going to need that, because the next question, part B, says, or actually part C says, come up with an error evaluation for this. So let's just go ahead and come up with a formula for our nth derivative. Okay, so this basically says I've got a minus 1 that's oscillating. So the minus 1, I've got, whenever I have like an even, let's see, an odd power, right? So this is minus 1 to the n, essentially, right? Because when I have an even power, they cancel out, and then the minus 1, so I've got a minus 1 to the n, I've got a 1/3 right? On my third derivative, I have 3 1/3. Oops. On my second derivative, I have 2 1/3. On my first derivative, I have 1 1/3. Okay, so I've got basically n 1/3 that are happening. And I've got e to the minus x over 3. Okay. Now I'm going to take a look at my n plus first derivative, n plus first, and x, and I'm just basically going to add 1 to all of my n's. So minus 1 to the n plus 1, 1 over 3 to the n plus 1, e to the minus x over 3. Okay, this part here, right, I'm not going to worry about the minus 1 when I do the error calculation because I'm taking the absolute value of it. But this part right here I'm going to be using, like this n plus first derivative, I'm going to use when I do my error calculations. Okay, we'll get to that when we look at part C. Okay, so let's take our coefficients here. Again, I'm going to plug them into the general form of our Taylor, or Maclaurin in this case, in order to come up with our equation. 2, 3, x equals, so my function evaluated at 0 is equal to 1. My first derivative evaluated at 0 is minus 1/3 x to the 1, plus my second derivative evaluated at 0 is 1/9 x squared. Don't forget, this is over 2 factorial, plus my third derivative, minus 1 over 27 x cubed over 3 factorial. Now, you're free to leave it in this form here. I'll put an underline on it. Okay. If you want to multiply everything through, make it look a little bit more clean, you totally can. Or you can just leave it like this. It's fine too. But let me just go ahead and do that so you can see what it looks like. Minus 1/3 x plus, right, this is 1/9 times 2 factorial is 1/18 x squared minus 27 times 3 factorial. 3 factorial is 6, right? This becomes 1 over 162 x cubed. So if you wanted to multiply everything through, if you're not quite sure, you can just leave it like this. These are both fine. I will take both of these. Okay, so that's part A. We just needed to come up with the Maclaurin for that. Part B says, okay, use your answer in part A, which is this equation right here, to come up with an approximation for, we want to find the value of e to the minus 0.1. Okay, so there's a little bit of a trick on here. This isn't telling us what x is equal to. This is telling us what our total equation is equal to. So what I'm going to do is I'm going to take this and I'm going to set this equal to minus x over 3. Okay, and I'm going to solve for x because that's going to tell me what x I need to plug into my equation in order to get the answer. Okay, so when I solve for this, right, I'm going to get minus 0.1 times, and I'm going to do minus 3 equal to x, and my x is equal to 0.3. So this is the value, x equals 0.3, that I'm going to plug into my equation right here. Okay, so I'm going to go ahead and do that. So I'm going to look at 2/3 of x, this is 0.3. I'm going to go 1 minus 1/3. Everywhere I see an x in my answer for part A, I'm going to plug in x equals 0.3 plus 1 over 18, 0.3 squared minus 1 over 162, 0.3 cubed. Okay, and now I just did it by my calculator. Let's see if I can bring it up on my calculator. Be very careful when you're doing this out on your calculator that you are mindful. Okay, let me just show you what I have on my calculator here. So I plugged it all. This is what it's in dark right here. So everywhere I see an x, I plug in a 0.3, right? And then I just basically work my way through the equation here. I don't know if you guys can see that okay. That's coming up on the screen. Anyway, I plug that in, and then essentially what I get is 0.904833333, and then I go off the screen. Okay. Now just, this is your answer right here. Okay, so I'm going to go square around this. Just as a sidebar, if you just want to confirm it, so by my calculator, this is just for me to check on my own. This isn't what you would write down in your answer, but you could do this e to the minus 0.1. I plugged it in itself. I get 0.904837418. Okay, so that's a good cross check, right? Look, it's almost identical, except it breaks down here at this particular point. Okay, so we're going to calculate. Part C is calculating the error calculation. Okay, but just to kind of see if you plug it into your calculator that you're getting something along the same ballpark, right? Relatively speaking, is what you got from your formula. That means that you know that your formula was correct and that you calculated your x value correctly when you plugged it in. Okay, so part C says, calculate a reasonable error. Right, so if we're going to assume our absolute value of x is less than or equal to 0.1, here we're going to find a reasonable upper bound of error by approximating the same Maclaurin. Okay, so we're doing the same Maclaurin that we did here. Okay, and then we're looking at a narrow window around our x is equal to 0. So we want to look at plus or minus 0.1. Okay, so let's go ahead and write that out. So I'm going to go minus 0.1 is less than or equal to x, which is less than or equal to 0.1. Okay, this is all just like our absolute value calculation here. Okay, so now the question is, right, this we're looking for the error, or third degree error here. Okay, so the error calculation, remember the formula for that is I'm looking for my max of, let's do this, f of, this is our third degree, so this is going to be n plus 1, so 4 of z. Z is some value between x and a. Okay, so our a value is equal to 0. So we're looking at a narrow window around here, times absolute value of x raised to the n plus 1 all over n plus 1 factorial. Right? This is our third, this is n plus 1, this is n plus 1, this is n plus 1 factorial. Okay, so keep that in mind. This is your formula that you're looking for. This part here is the most complicated part, right? That's the part that you have to make some decisions on. Okay, so now back to our window here. So we're looking at a range of values between minus 0.1 and positive 0.1. Okay, so I'm looking at my function e to the minus x over 3 is a decreasing function. Decreasing function. Okay, if you're not quite sure, go ahead and graph it out. You can take a look at the graph. You can see, especially within this interval here, it's a decreasing function. Okay, so in order to maximize this, right, I need to choose the lower bound on here in order to maximize my fourth derivative evaluated at z. The whole point on here is to choose a z value. So I'm going to choose my z is equal to minus 0.1. But look, I can't choose a minus 0.1 because it's too close to the value that we're actually doing. Remember, e to the x is actually within our derivatives. Remember all of these derivatives that we have. So I can't just plug in, 0.1 here because it's a part of my derivative. So I have to choose a value that's slightly, choose z that's slightly, and I'm going to go slightly lower than minus 0.1. So just for ease of it, I'm going to choose a z equal to minus 0.3, just because I know it's going to divide things out. Let's see if I can get my window up. There. Okay, so if I choose z equals 0.3, that means when I plug it into my max, right, so my max value is going to be max, right, it's going to be the absolute value of, I'm going to go 1 over 3 to the 4th. Whoops. This all comes from, right, remember those derivative calculations that we came up with, right, so this is 1 over 3 to the n plus 1, so that gives us 1 over 3 to the 4th, okay, so it's going to be times e to the minus 0.3 divided by 3. Okay, this comes from our formula for the derivative. Times, I'm going to plug in the rest of it, okay, which gives us 0.1 to the 4. This is our x value divided by 4 factorial. Okay, so this right here, when I multiply it out, right, so this gives me e to the 0.1, okay, times 1/3 to the 4th. Remember, it's absolute value, so that negative 1 to the 4th power is going to go away, so we don't have to worry about that. So this is equal to e to the 0.1 times 0.1 to the 4th all over 4 factorial. And that gives me an error of 5.68 times 10 to the minus 8. Now, on this particular problem, there's no hard and fast rule for choosing your z value. Like say, for example, you chose a z value. Let's say, for example, you chose a different z value. So z was going to equal to minus 3, right? So if z was equal to minus 3, that would give me an e to the 1, okay? That means I would take e to the 1 instead of e to the 0.1. Looks like I forgot my 1/3 to the 4th. Sorry about that. So 1/3 to the 4th. So I would get e to the 1. I'd plug that in instead of e to the 0.1. Okay, that would give an error equal to 1.39 times 10 to the minus 7. Okay, so you can see, I mean, like, I'm still, roughly within the same ballpark. We're looking at things that are like right around here or right around here in terms of our error calculations. These are both correct answers. Personally, as long as you show me your logic for how you're choosing the z values, I'm going to give you credit for it. It's not going to be a problem. Okay, so just make sure you choose wisely, right? And you explain your choice. Okay. So any particular answer is going to be fine as long as I actually see how this is. Maybe you even wanted to change this e to the 1 is like, close to 3. Maybe you just substitute this whole thing in for 3. So instead of e to the 1, you're going to get 3 here. So, all of these things you can make that decision for and just state it, what your assumptions are. Okay. What I'd like to do, I know that I have some participants here. So what I'd like to do is I want to end the meeting just briefly so that I can get a recording and post this recording so that the recordings don't become like an hour long, and they become segmented by the final exam type. So what I want